perspective of how deep it was. Now, something that's interesting to know, here is an example of a well within a Naragi itself. It's under this grate right here. And it's in a centralized location within the Naragi. It had some sort of importance, obviously. Water is very scarce on Sardinia. It's a pretty arid island. Rainfall is measured in millimeters annually. So, okay. If you go to Sardinia now, you don't have to worry about getting malaria. It was eradicated during the Sardinia project, which was from 1946 to 1950. And when they were doing this, they found that actually within the wells, the previous one that I just showed you, they could not find any mosquito or larva from the mosquitoes, which is really pretty interesting to me, right? I was excited when I read that. However, in the Naragi, and some people have hypothesized that these kind of serve as a protection from mosquitoes. Obviously, they weren't these warriors, or at least we have no evidence of that, so what function did these serve? They found mosquitoes, female ones, resting along the walls of these structures. Oops. Okay, finally, another archaeological feature that you'll find during this time are these giant's tombs. And unfortunately, a lot of them have been disturbed. And the numbers of individuals that have been found don't necessarily reflect or don't seem to reflect the whole population. So we have some burials that are just not accounted for in Sardinia. We haven't been able to really find them too well. So most likely, people who are in these tombs, there's something special about them. They're either elites or maybe they were warriors, although there's not really that evidence, but they might have served some sort of function that way to serve as a burial for special people in the population. In this forecourt, they would have ceremonies before the interments into the tomb. Okay. So next, the ecological data that I looked at. Really, there was this cooling trend that occurred right before the Bronze Age. But what we have found is that there was substantial deforestation that occurred when species were introduced during the Neolithic to clear the lands for grazing and farming. And when you do that, you strip the topsoil off, and it can create this kind of clayish underground that keeps the water from being absorbed appropriately. And you get these stagnant standing pools, and mosquitoes like them, right? So you see this destruction of the landscape or modification of it, and it becomes very conducive for the breeding of mosquitoes. Also, the environmental data indicate, or at least suggest, that these mosquitoes that can transmit malaria were probably on the island for millions of years before humans actually set foot. And beyond that, they occupy just about every level of elevation on the island. And they have no competing species. So they pretty much have the run of the place. From a mosquito's perspective, it's not too bad. Okay. This is an example of one of the smaller Naragi as well. Also, something that's interesting is there's a lot of gaps in the data. So that would be a good research project for somebody in environmental sciences if they wanted to reconstruct this data as well. Okay, I also looked at the ethnographic information that's been published. Peter Brown, from memory, has done a lot of research with this. And, he has discovered some really interesting things in terms of Sardinia in particular. But overall, if you consider what malaria is, from a linguistic perspective, it means bad air. So this gives you an idea of what people were associating with these fevers that were from this parasite. They were thinking that something was wrong with the air, malaria, okay? And this leads to a whole bunch of other different folk etiologies in terms of the disease. drafts that can cause these fevers. You get chilled by a draft and your body tries to warm itself back up, so then you end up contracting this fever or malaria. And another one is temporary, and that is a change from hot to cold, going from hot to cold or cold to hot, and your body trying to regulate its temperature. And as you can see, that this is something that you probably have heard of yourself, or your mother might have told you, don't go outside without your jacket, you'll get sick. And the association might be based in this. So when he interviewed some of these people, some of these older individuals who were alive during malaria outbreaks, what he found is that having a malaria infection was not something that they would let slow them down. In fact, it was seen as a sign of weakness if you weren't out working when you had this malaria infection. And they would combat it by drinking black wine. Now, Sardinian wine has one of the highest levels of polyphenols, which is actually, or has recently been discovered to have these antiprotozoan properties to them. So that is one indication of things that they might have been using. Get a bottle of Sardinian wine, it's not bad, to combat malaria. Some other things that he found were the settlement patterns were very nucleated, and there was a high level of endogamy too among these individuals, because they would live in these communities that were geographically circumscribed by mountainous regions or very arid, long places in between getting from one village to another. In the winter, they would practice inverse transhumance, which means that they would, the flocks would travel to the lower elevations during the winter time when the mosquitoes were less active, and they would reside in the higher elevations too. Okay, so from a biological standpoint, there are two conditions in malaria that are associated with, they're genetic conditions that are associated with malaria in Sardinia. One is thalassemia, and the other is the G6PD deficiency. And in fact, the G6PD deficiency has its highest rates. Most of the cases of it are actually from Sardinia. And researchers believe that in terms of evolution, these are the first two adaptations that tend to evolve in a population. And there's several variations of them throughout the world. But these are the first that you see, and it takes a couple of 100 years before you see them after living in a malarious environment for them to show up. And G6PD deficiency, something of note, if you're familiar with favism, what it does if you have this condition and you consume fava beans, it gives you an edge, basically, in a malarious environment. But if you are not in a malarious environment, it doesn't really benefit you too much. Okay, so what I tried to do is identify if we could actually see evidence directly of malaria in the skeleton from these people, or if I could see indirect evidence, meaning evidence of thalassemia and G6PD deficiencies, both of which are anemias. And thalassemia itself has this pattern that it displays on the skeleton, where you may have heard people describe diseases in terms of facies and how they look when they have a disease. If you have thalassemia, you might be described as having this rodent facies or a rat facies. It causes the jaws to kind of become inflamed. Your cheeks, your jaws will be malaligned. You'll have malocclusion. You might have some deformities of the long bones as well, and of course anemia. G6PD deficiency also results in anemia too. So, in skeletal remains, one of the primary indicators of anemia that is used is, are a couple of conditions. One is parodic hyperostosis. And what parodic hyperostosis is, and it's on the left-hand side right here, is when the bone in the inside of the bone, which is more spongy, kind of expands because the bone marrow becomes hyperactive. It's trying to make up for the destruction or loss of blood, loss of iron in the system. So it becomes very active, and the bone marrow itself expands, and sometimes can wear through the cortical or thicker bone on the outside of the skull in this case. Criborbitalia is this condition in the eye orbits. Now, these conditions are not exclusive to anemia. They might occur if there's a nutritional deficiency elsewhere, another type of nutritional deficiency, or diseases such as scurvy. However, scurvy shows up later in the archaeological record, not in the Bronze Age so much. You don't see that. You can tell the difference by doing histology or radiography. Another thing I did was I actually did chemical analyses to test for malaria, DNA, ancient malarial DNA, protein that people have when they are infected with malaria, and hemosome, which is a waste product of the malaria parasite. It's a biocrystal that can be detected a couple of different ways. Now, I used the tomb of Ceres Socadema, tomb B. It's actually a complex of two tombs. Tomb A had been looted. Tomb B they discovered when they were expanding the road in the early 1980s. And something else that was really interesting and appealing was this feature that I was telling you about at the beginning of my presentation. And what this is, if you can see it, is actually a circle of skulls. This is the oldest level in that feature, the cyst outside of the tomb. And they are juveniles. And their skulls are arranged in a circle. And the only other skeletal elements in this structure are long bones. The rest are not present. There were also fetuses that were found here as well. So after I did this analysis, there were 239 people at least, and the remains were very highly fragmented that I went through. You can see that there was this high rate of chronic hyperostosis and criborbitalia. So that got me pretty excited because it was kind of in line with what I was expecting to see. But how did I know if that was related to an anemia related to a disease or maybe some sort of nutritional deficiency? That was the question. So I looked at the nutritional data and I kind of reconstructed what their diet would be like, what nutritional value their diet had at the time. And the conclusion that I came to was that basically it was probably because of some sort of parasitic infection. That was the only thing that really fit the pattern that I was seeing in these skeletal remains. When I did the ancient DNA tests, I was very excited to find out that 4 of them came back positive, and then very heartbroken to find out that we could not replicate the results. And then the protein did not come back positive. They could detect protein, but not the one we were looking for. And the hemozoin, which is important, one sample, sample number 5, came back with kind of these inconclusive peaks. We weren't sure what we were seeing. Something was registering. All right. Okay, so gave you the osteological conclusions. From an archaeological standpoint, I think that there is something about the way they managed water that would have helped them survive in a malarious environment, and that actually warrants more study and investigation. The Nuragi themselves, without further modification culturally, didn't really give them any benefit because it was causing all the people to become nucleated, which could cause malaria to spread more efficiently, and there was indication of the mosquitoes residing in that. Okay, so this is where I found out what I did wrong, basically, with my project. In 2010, I ended up at Wayne State, and one of my students came up to me, and she does histology, and she said she wanted to do some histology on the skeletal material, and I thought that was great.